Happy Saturday, hackers. Welcome to Saturday Hacker Day. My name is Taggart, and on this stream, we're going to be doing some security, some CTFs, some programming. Today, we're going to be doing some more forensics, digital forensics and incident response. We're going to hopefully finish up the banking troubles challenge we did a couple of weeks ago, and then we're going to move on to doing some actual image forensics with Autopsy. Pretty excited about those things. But first, as always on Saturdays, we're going to start with some of the week in cyber news. The first item I don't think really needs any more coverage, but I thought it would be remiss in my cyber duties if I did not mention the Facebook breach, or face breach if you want to save a syllable. Of course, Facebook had a breach of over 500 million with a Carl Sagan B, emails and potentially phone numbers, basically account information. And so if you want to go check out whether you have been included in that list, you should go check out haveibeenpwned.com, check your email address and see if you're included in that or any other breach, as a matter of fact. If you've never gone to haveibeenpwned.com, really, really important service for the community, so make sure you check that out. Check that out for yourself and for your loved ones. The other piece of news that I wanted to touch on very briefly today before we dive in is some cool news from the Android world, in that Android is now going to begin supporting Rust code natively. Now, this is a little bit in the weeds, and let me tell you why I'm excited about it. For the longest time, if you were writing mobile applications, Android meant that you were writing in Java. And if you were writing for iOS, let's just take those two platforms. There were others at some point in history. But if you were writing for iOS, of course, you were writing first in Objective-C and then over in Swift once Apple released the Swift programming language. Pandacat, Lasso, welcome. Good to see you both. And then, so in that situation where you had Java on the Android platform and Objective-C and Swift on iOS, you had a certain performance problem. For one, because Objective-C compiled down to native code, right? And Swift does the same thing. Whereas on Java, right, you're working in the JVM, the Java virtual machine. So you've got this extra layer, right, before you get down to the zeros and ones that interact with the processor. For that reason, Android performance has always really lagged behind iOS. And even, when extra kind of abstraction layers like Kotlin, which is a Java flavor essentially, was added to Android, you still had that performance penalty for using that Java virtual machine for the software that you wrote. And not just performance issues, but also security issues, because Java has a lot of the same sorts of programming issues that you would run into in C or C++. Memory management is a real challenge for this language just by its design. Now, Rust, by contrast, is designed specifically to avoid a lot of those memory management issues. It is very strict about what you can do with different parts of memory and how things are allocated and freed. That, plus the fact that it's native code, means that it's rip-roaring fast. So the fact that Android is now going to support Rust code natively means, or potentially means, a lot of performance improvements for Android applications as well as security improvements for the platform. I'll also just mention that this comes on the heels of the Supreme Court decision in favor of Google in the Google versus Oracle suit that's gone on for I guess, a decade, right? In that, re-implementing the Oracle APIs in Java was, it turns out, a legitimate use. But I have to wonder if the Rust implementation in Android was kind of a backup plan in case they didn't win that case. If they had to give up their Java API, and what were they going to do moving forward? I have a suspicion that they had this plan in their back pocket just in case they were forced to essentially de-implement or decommission all of the Oracle APIs that they had implemented in Android and had to find some other solution for developers. This would have been a massive change if they had to do it, but at least they would have had something in their back pocket where they would have been able to allow programmers to continue to write code on their platform. But either way, whether it was for that or not, the fact that Android's now going to be able to use Rust code, I'm very excited about. I don't like mobile programming at all, but I do like Rust programming, and so the ability to get code on a mobile device with Rust is exciting. All right, with that, let's move on to the main material for today. We're doing some forensics, so we're going to split our time today a little bit. The first part, we're going to kind of revisit the banking troubles challenge in Cyber Defenders that we were doing 2 weeks ago and see if we can finish that up. I've learned a little bit in the interim and would like to knock off some more of those questions. Then hopefully we'll be able to move on to some Windows disk forensics, and you will be using the Autopsy tool to make that happen. The plan, I will admit, the plan for today was to finish up doing the Security Onion overview. But man, that VM just does not want to play ball with me for a bunch of different reasons, whether it's internal networking or whatever. So still need a little bit more time to get that to where I want it before it's ready to present to all of you fine folks. But once it is, I promise we'll go over Security Onion together on this stream. But for now, let's get forensicing. That's a verb. Alrighty. So here we are in Cyber Defenders. Let's get some music back. Nice. So we've got Cyber Defenders up and running here, and we have answered most of these questions. Well, I don't know about most. Yeah, no, it turns out most. But there's a lot that we haven't done here. But let's go over what we've done so far. And of course, like a chump, I didn't actually, take notes. So we'll quickly run through some of the things we've executed with Volatility, our memory forensics tool, before going forward. So just to remind everybody what the premise is here, we had Company X. They contacted us to perform forensics work on a recent incident that occurred. You can zoom that in just a little bit so it's easier to read. One of their employees had received an email from a coworker that pointed to a PDF file. Upon opening, the employee did not notice anything. Okay, so we know we have kind of an entry point of the PDF, right? And then we have the memory image. Now, a couple of things that are really, really worth calling out. So I was pretty much just using Volatility, but there's other stuff that we can use, right? So PDF tools, Firebug potentially, and Foremost. Oh yeah, definitely Swag Shop on Tuesday. Yep, that's the offensive stuff, so we'll be doing that on Tuesday. We'll finish that up. Oh, that's a little aggressive. All right. So let's check out PDF Tools and Foremost. So PDF Tools is from Didier Stevens. We've used Didier Stevens tools on this stream before, where we've used OLE dump to get information about Office documents that are evil. But PDF parser is a great tool that will actually go through any PDFs that you discover and kind of break them down. So we'll go grab PDF parser here, and we'll save it in the we'll save it in here. Just kidding. We're going to save it in scripts, because we're probably going to need it for other stuff, too. So let me quickly unzip that. Okay, so we have PDF parser that's going to be useful for us later, but let's talk about where we are so far. So I did some basic enumeration on this just here, and you can see there are a couple of processes that we might be interested in. We have Firefox, and we have there it is, Acro Read. So we know if it's a PDF that, you know, a PDF reader was involved, and sure enough, we have the Adobe Acrobat Reader here. And does PS-Tree give us anything? Not really. But you can see that this is interesting, that Firefox has a parent ID of 1756. That's VMware. That's okay. Never mind. That's not interesting. I was thinking 1752 for Acro Read. But, so other stuff that we can do with volatility, right? We can let's get our help up for volatility, actually. So we have all of our plugins ready to hand. So we can do things like the DLL list, the print list of loaded DLLs for each process. So if we wanted to look at 1752, right? 1752 was the... was the Adobe Acrobat. So if I wanted to do DLL list and give it a PID of 1752, then I could see the DLLs that are loaded there, except that... Was it... -P? Hey... Oh, DLL list. It's 3 L's. And here, right, you give it the PID. And we'll give it 1752. And so we might want to see if there's anything interesting here that got loaded that you wouldn't necessarily expect. There's obviously some network connection stuff going on here, so that's worth thinking about. What other tools do we have? We have our connections, right? So we can look for just straight up connections to see what was available. And sure enough, we have a connection from 1752, which we found that was kind of evil, and 888, which was Firefox. And if we look back at our answered questions, we found that this 215 was a little bit suspicious, and that was opened... I'm sorry, 212. I don't know why I said 215. Was opened, and that came from the Firefox instance. And if we wanted to, this PHP is kind of interesting. Now it's asking us to look at the service memory for that. So how did we do that? We can do a strings run against, you know, the entire thing. But we can also just do a process dump, right? So if we wanted to do a process dump, we could see what was going on inside of that specific process, right? And that may be of use to us, especially if we're talking about going after this acro read. So we could do proc dump key of 1752, and we're going to do destination 1752. Except, yeah, we have to make that directory first, 1752. And now it'll dump that process information. All right, let's move on a little bit here. So what we need to do is dump out some more of this data to get this information. So let's see what we got with that dump. All right, looks like we didn't find much there because we just got the executable. It looks like for that we didn't get the data from it. Let me see if I can remember what we actually need to do to dump. Oh, dump the addressable memory. That's what it is. It's mem dump for the process, not proc dump. So let's make the dir 1752 again. And then we'll do mem dump. That's better. Try to take some notes here. And I'm hoping that we don't run into the same sort of file write issues we were having on Wednesday. Where we discovered that WSL2 has some real file write challenges. When running under a Windows file system rather than the Linux file system. All right, while that's running, let's see what else we can go for. So we're going to try to dump this, and we're going to see if we can rediscover this URL, kind of get back to where we were. And then once we get that, we're going to need to use the PDF tools to go after the components of the PDF. So the problem with PDFs is that they're not not plain text format. They're actually a pretty complicated file format, and it takes some serious parsing to extract data from them. And the other thing I'll mention about PDFs is that there's no real standard to them. There are a lot of ways to make a legible PDF that a PDF viewer can read and that you can look at reasonably. And often the objects tree that is backing up what that supports what that PDF is presenting, it's not nearly as clean as, for example, what you would get with HTML. It's a lot more chaotic, and that's why you need tools like this to go after it. Let's see what we have in PDF tools. Looks like we got our dump. So let's first, we'll start there, and we'll do strings. And we'll grep for HTTP just to see if that gives us anything. You see, obviously, we're getting a lot more. We've got this network plus load.php. Okay. A lot of URLs. Now let's try grepping for PHP and see if we can do any better there. So obviously this pdf.php, that's something. And we have this pdf.php right here. And does that track with what we had discovered? No, but that's because it was in the service host. That's what we had gotten before. But we want pdf.php. We want this file. So how do we get it? To get it, we're going to use foremost to get files, to get the PDF files out of here. So to do that, foremost, I already have it installed. -h, right? So we're going to do foremost, and we do the file type of PDF. And the input file is going to be the 1752.dmp. And let's actually make a new folder in here called PDFs. And then we'll do foremost. The input file is going to be 1752.dmp. Then the type is going to be PDF, and the output is going to be PDFs. I'm really hoping this worked out. This is where we got stuck last time, by the way. Okay, we got some PDFs. That's interesting. So let's go back to Cyber Defenders and see where we are. One file has an MD5 hash ending in the 65cc. So let's see if we have one of those. And to do that, just really, really quickly, what we're going to do is use fish to write a quick for loop. So for f in ls here, we're gonna MD5 sum the file. And what was it, 65cc, right? That looks pretty much like it. So 601560.pdf, that looks like our target, right? So now that we have the PDF that we needed, what we can do is we can run PDF tools against it, I think. Let's see how we do. So PDF parser. Yeah, that's what we need. So we're gonna do Python 3 scripts, PDF parser.py. Let's just get the help for it and make sure that we... So the PDF file is a positional argument, so we'll give it that. And what do we want to do? We want... Well, let's run it without anything, and we'll just give it the... $1560. One thing I love about the fish shell is that I can give it a part of a file name, not even the first part, and it'll try to autocomplete the rest of it for me. All right, well, that's a lot. Let's see if I have other tools with PDF parser that will help me parse that out. Let's search for PHP. Oh. I have to give it the file. All right, that didn't work out super well. I wonder if this is the right tool. We just kind of grabbed the first one, but there's also... Let's see what else Didier has for us here. It's PDF parser. That's the whole thing. But PDF ID... Oh, it looks for JavaScript. Let's see if we can do better than that. No, those are all comments. Well, let's get PDF tool. and get that extracted. I also know for a fact that Didier just has the Didier-Stevens suite. And I wonder if, and that's on GitHub, and I wonder if it's just worth grabbing the whole dang thing. Let's see what he has in the PDF section here. Oh, we have PDF tool, and okay, so I think we have everything that we would want already out of this. So let's try PDF tool. Come on. Okay, we're going to do an ASCII dump of this thing, and we'll give it the 1560 PDF. Available commands, IU. Okay. That doesn't really give us a whole lot of information here. Pretty much just tells us what we knew, which was the hash. See if his documentation has anything else about it. There we go. It takes commands. This first version only has one command. That's not at all helpful. Oh wait, am I misreading this? Oh, okay, yeah. So I'm just bad at reading Didier's output. Basically, what we want to do now is select, right? Select one, and then do an ASCII dump, and I think that gives us... Yeah, there we go. Although... God, that's a lot of output. Do I have to put the -A first? Because I don't want... All right, let's look at the ASCII dump here. Interesting. All right, well, this is gigantic. So actually, I think what we want is just a dump. We'll call it PDF dump. Yeah. Now, can I run strings on that? I can. Okay, didn't give us much. Let's take a look at the let's just look at the strings in general and see if there's anything in here that's... That's not super helpful. Because it's, you know, it doesn't have a whole lot more than we expected it to have. Now, interestingly, if I run strings against the... So I don't... Okay, so I don't get anything there. It's really not that much different. Let's take a look. I want to see if there is something else in... Is there JavaScript anywhere in this? Let's use grep. So the 1560 does match, but it's pretty much for the same reason, right? We have the localization.js. The reason I'm looking for JavaScript is, if you remember, we need to find PDF. We're looking at the wrong dang thing. We need to find PDF.php. That's our problem. Yeah. We need to find pdf.php wherever it was. Because we found it in the memory, right? The mem dump. Yeah. We found it here. pdf.php. So what can we use? Do we have anything in Volatility that can help us get that file? Because I think that's what we need. Full scanner for file objects. Yeah, let's try that. And let's just see what we have. Can we specifically look for a given file name? Doesn't look like it, so we're just going to run file scan here. And right, this is going to take a million years. I'm going to kill it, and then I'm going to grep for pdf.php. See if we can find that specifically. For any new viewers, welcome. And if you wanted to play along at home, what we're doing is cyberdefenders.org. You can set up an account for free. And the tool that we're using is Volatility, which you can download from volatilityfoundation.org/releases. You can get it for Windows, Mac, or Linux as standalone. So just download it and put it someplace in your executable path, and you can run this as well. Oh, dope. Okay, so we did find it. That's very exciting. So what we want is to dump files. I believe. We just need to give it the physical offset, I believe. So which we just copied. And then we'll dump it here, just for now. Is it the... Let's do the whole thing. We'll dump it and we'll let it go because that gives us more information, and we'll say that we save the information. That's probably smart. But while that's doing its thing, I want to look at the columns. So, oh, it's the physical offset. Okay, so that's one of the reasons why we didn't get it right. So, all right, let's remove the VACB file. And we'll do the dump files, but we'll do the physical offset, right? Instead. What's the... By the way, I'm sorry, I should explain offset. So if we think about, let's go up to our notes here. if we think about the memory space for the entire memory image or for a specific process, it has a beginning and it has an end. And what we want to do is figure out where to start looking. And so that's what the offset is. The offset is the address, it's the number of bytes to look after the beginning of the memory space, and that's where we begin our search. Okay? And it will search until it discovers either what looks like a new file, or if we're doing a process, the beginning of a new process. So that's the idea with the offset. That's what that means. Now, what's the difference between a physical offset and the physical address offset is that one of them is for processes and one is for the disk itself. But, you know what? There's an easier way to do this. We have the R, so we'll do, let's see if that does anything for us. So we can do it with a regex. That might be more handy. We'll keep running this till the top of the hour, and then we'll switch over to do image forensics because I really want to do autopsy today. Which maybe we'll tee up while this is running. So we're doing the image forensics that we're doing is corporate secrets, and it's gigantic. Fair warning. So in case you wanted to download it, it's like 12 gigs. I have downloaded it and extracted it. Yeah. So the first thing we'll have to do is import this into Autopsy. FTK Imager, by the way, that tool that you may have seen in that README, is the tool that you would use, or a tool that you can use, to create a memory, not a memory image, a disk image during a forensics investigation or incident response. It is free to use and works great. Now, you can also use, like DD if you want to, which I've done before, right? If it's a Linux system, you could do that. But what you want to do with disk forensics, the trick is to preserve the disk as much as possible, right? So actually, you don't really want to boot up into the operating system if you can avoid it once it's been powered down. And so if you think about the entire process of digital forensics, let's say you had to do a full-out investigation, right? The first thing that you would want to do is the memory forensics, because it's the most volatile of the memory, right? As soon as the machine is powered down, you lose everything that was in RAM. So that's the first thing that you grab, right? You also would probably want to do a packet capture, a Wireshark or TCP dump or something like that to get any network forensics, any telemetry from there before shutting the machine down. Now, Once you've captured everything you need that's volatile, and you've contained the machine, you do want to power it down. You want to be able to create a disk image of any of the storage that's on the machine. To do that, you're going to want to use, there are some specialized tools that exist to do this, but you can also use, a special, you can create like a Raspberry Pi that does this, or just use a Linux flash drive or something to boot the machine up to that rather than to the onboard disks. And from there, you create your image. Now, you can use FTK Imager, you can use, as I said, DD, and then you take that image, you store it someplace secure and encrypted, and you do your analysis off of that, not off of the actual machine. But when you do that, when you do make your copy, I should mention, this is an important process, folks, process piece for anybody who is interested in getting it deeper. When you do your copy, okay, first of all, every step of your process that you do during an investigation must be noted and logged, right? And somebody's got to be witnessing what you're doing, because you never want what your activity has been to be in question. Okay, but once you are ready to create your disk image, you want to make sure that you have a before and after hash, a checksum of the disk itself. If you don't, you have a problem, because there's no way then to mathematically or cryptographically verify that the image you're working from is the same as where the incident took place. Okay? That's why, so you want to create a hash of the disk as it is. Then you're going to want to copy, you do a DD, create your image, to an image file. Don't image to a partition if you can avoid it, because the partition, right, depending on what happens with the physical disk, that hash may change, right? So, but that's much less likely to happen if you do it to an image file. So you DD to a file, and then that file is what you use for your investigation. Let's see how we're doing on our file dump here. That's not how you spell file. So it found pdf.php. It seemed like I was able to get it. Even though it found the PDFs. Wonder if there's something I don't know about dump files. Files are cached in memory, persistent performance as they are used. By default, dump files iterates through the VAD and extracts all files that are mapped as data section object, image section object, or shared cache map. You can use the R and I to specify a case-insensitive regex, like a file name. In the output below, Oh, interesting. So we get the offset in the file name. And then, oh. Okay. So once we have it, so we have this offset. So I wonder if once we have this, we can actually go and get the thing and see if that does any better. Although I don't know why it would. If it found it, why didn't it just extract it? Oh, but maybe... Okay, maybe that's the way to do it, where we can actually get, if we have the summary. Um, Alright, we'll let that keep going. Since we're getting close to the top of the hour, excuse me, let me fire up Autopsy here. And get this ready to go for our next thing. I was really hoping to get further than this. But here's what Autopsy looks like. And we'll start a new case. And we'll call it Banking... Nope, Corporate Secrets. And it is... Autopsy is designed specifically for forensic case working, right? So it's going to ask you to do a case number and the examiner name, like all this stuff. It is specifically designed to help you do your documentation. So if I do, number, you might have a whatever numbering system, right? So it'd be like 2021 03. What's today? The 10th. Like 1 if it's the first case of the day or something like that. And you can do, since it's a lot of times forensics work is outsourced, right? You can set up that you can work for different organizations. So we're going to add a disk image, I think. And it found the EO1 file, so it knows how to parse the rest of these, luckily. And then it has these ingest modules that'll run when you import the disk image. And we'll run all of these, except for the iOS analyzer, and I'm going to leave off the Yara analyzer for a moment too. And the virtual machine extractor, the Android analyzer, because we know that this is a Windows machine. Anything else that we can turn off? We definitely want the email parser. Hash lookup. Yeah, we'll leave that on too. And then we're off to the races. You can even see the files as they're coming in. Pretty amazing to see this happen. I don't know, maybe it's not amazing to you, but for me, I think this is kind of cool. This is the 12 gig file. This might take a minute. Give me my PDFs, man. All right. Well, something moved. So you can see we have this 1752 is the PID, I think, and here's the offset, which is interesting. So I think we do have, let's see. So we have the data section object. Right, and it came from 1752, which was the Adobe Acrobat. Now we've extracted the PDF files from oh man, that finished a lot faster than I thought it would, to be honest with you. All right, well, pause on this for a second. I just want to check one thing here. Oh, okay. Nope. I don't want to make. So PDF ID, is it the one I don't have? Did we not use PDF parser correctly? Maybe that was our issue. Yeah, I guess we'll search for JavaScript. I don't know if that's really going to work, but we'll try it. It was with 15.6. Yeah, I mean, it found it, but it doesn't really extract it. Oh, crap. We did find JavaScript in here. A apply function, this mouse out, if s in a number. This doesn't appear to be super malicious. This just appears to be some sort of UI thing. But we still don't. The problem is we still don't have PDF.php. I guess that's the issue. Is we still don't have that thing. But it was loaded by 1752, so it should be in here. Okay, let's try this. Grep R for function. We just don't have PDF.php. We'll move on to the disk image forensics in a minute, but I feel like we're so close. Okay, so check this out. The PDF parser gave us this object information, object 11, and in the help, we give it, is it, what was it? Yeah, dash O 11, and we give it the okay, then it says referencing 1054. What if we do a raw output? What does filter mean? Oh, pass the stream through a filter. What kind of filters do we have? Pass stream object through filters, flat decode, ASCII hex. What if it's indirect object? No. Can I give it a specific? Or maybe verbose? Ah, we're so close here. If we do raw, contains string. Stream object through filters. If I just try it through ASCII, can I give it a filter? No. It says ASCII 85 decode compress failed, but I don't care. Oh, wait, there's an overriding filters. Let's try this. Overriding filters equals, and we just do that. Unsupported filter. What about just flake decode? Nope. It's right there. We give it 11. No, still definitely 1054 is where it is. You just cannot get it. I'm gonna take raw off. No better. All right, well, let's move on to Autopsy and see if we can have some fun with that. All right, so here we go, corporate secrets. Let's look at the challenge details first. No challenge details. We don't have any sort of premise here, so we're just going to have to use our imagination. So the first thing we're going to have to do is take a look at this. So size in bytes is, you know, large. Time zone is America, Los Angeles. I wonder if that's me. And over here we see our results. I know this is a little bit tiny, but let's first look at the operating system information. Okay. So what is the current build number on the system? Oh, we're analyzing. Do we have registry information? Well, it's definitely still processing stuff, like the system resource usage. Alright, so let's see. We'll leave this. We'll take a look at the hint, just in case. Where does Windows store? It's in the registry for sure. But we're still extracting this information, I think. But let's see. Let's look at our user accounts. No? Operating system user accounts. Okay, here we go. So we have admin, Jim Tomato, Tim Apple, cute. Okay, so 1, 2, 3, 4, 5. The administrator, that's built in. The question is, how many users are there? So we'll go with 1, 2, 3, 4, 5, 6. I think the answer is going to be 6. Yeah, okay, good. They're not counting the built-in admin. Oh, man. Hey, Chad. And everybody, welcome. Welcome, Raiders. We are doing some disk forensics with Autopsy. No way Tim Apple has a Win10 account. Nope, I bet that even Tim Apple knows that Excel on Mac is absolutely garbage. Slyborg, good to see you. Chat, I'm doing real well. Getting super frustrated with memory forensics, but we've moved on to image forensics, and hopefully I can do a little bit better here. What is the CRC64 hash of the file fruitapricot.jpg? Well, we got to go find the image, and the good news is that Autopsy will break this down by extension, images. And there is a search in here. Yeah, this is cyberdefenders.org. It has... Here's the thing about cyberdefenders that I think is worth mentioning. It does not, as far as I can tell, produce a lot of its own material, but it's a really solid aggregator for challenges from elsewhere that kind of end up living forever in this format. So, for example, this challenge is from the is it Indiana or no? University of Illinois, Champaign? Nope. That's a different thing. I'm thinking of Champaign-Urbana. But yeah. Champlain College Digital Forensics Association. And so that's kind of where this came from. Ugh, this song blows. Let's try this again. Alright. So yeah, it's a really nice, and the, some of the other stuff that they've put together are like from Splunk, right? And in fact, the Boss of the Sock stuff, at least the first one is on Try Hack Me as well, but Cyber Defenders has put it up as well. So, and the Flare stuff from FireEye for reverse engineering, it's all from other places as near as I can tell, but it's a great, single place to look for a bunch of these blue team challenges. Really excited to do these Maladoc ones in the future. All right. So we're looking for apricot here. And there's 1,000 results. There is an image video gallery, which is kind of neat. But you got to kind of know how to work this thing a little bit. And we don't know exactly where it is. So the specific question we're being asked right now is fruit apricot. So we're gonna go look for fruit apricot here. No! F-O... F-R. Oh, that's not great. Looks like we don't have... Hey, Holland, thank you so much for the follow. Yeah. Okay. So we found... Let's search for apricot... What is it? .jpg? Fruit apricot.jpg. It's interesting. Part of this is probably because we haven't finished processing this thing too much. It does take a while. Were all the images JPEGs? They are, yeah. Oh no, we do have some JPEGs here. I wonder if there was an apricot rather than... What do I find... Chad, great question. What do I find more challenging, red stuff or blue stuff? 1000% blue team stuff. And here's why. With blue team, first of all, you have to get it right all the time, right? with red, you know, you've got a lot of opportunities, a lot of targets to hit. With blue team, a compromise on one of your endpoints is, it's not a loss necessarily, but like, it's a lot harder to get everything right. And that's part one. Part two, during an investigation, you never know for sure that you got everything. You can't. Whereas during a red team exercise, for sure, you know when you've accomplished your mission. Right? If you've been able to infiltrate the network, if you've been able to gain a foothold, pivot, escalate your privileges, right? Get to the crown jewels, exfiltrate data, like those are obvious markers of success. Whereas with blue team, you're never totally sure if you got everything, and that's just for deeper. If we're talking about detections or threat hunting, you're working against the negative space all of the time, which means you're always working against doubt, right? You can never be 100% certain that you've gotten everything, and I find that a lot more challenging. Also, from a technical standpoint, not for nothing, but the tooling for the blue team just, like, sucks. It just isn't as well defined as it is for the red team. I'll give you a great example. If I'm doing an investigation on something and I have to look at Windows event logs, there are a couple of tools. There's, what is it, Deep Blue CLI? Deep Blue CLI to try to look for evil in Windows event logs. And there's, there are a few others that will like try to automate the extraction of Windows event logs, but if, let's say you wanted to go look at event logs if you had time, right? The only easy way to do a time-based review of what you're doing in Windows event logs is to do it via PowerShell. And I don't know if you've ever tried to do date time objects in PowerShell, but it's agonizing. Now, people can make their own PowerShell scripts to make that easier, but why should we all have to do that, right? There's just this massive dearth of blue team tooling in the open source community that I'd like to try to fix once I get good enough to contribute, but I can't be the only one, We don't have, so for example, I don't know if you know who Marcello Salvati or Bytebleeder is. He wrote CrackMap exec and Silent Trinity and a bunch of other cool stuff. There is no Marcello Salvati of the blue team, right? There's nobody who's making these amazing tools for us to all use. Or if there is, that's fantastic. There's a lot more, I'll say there's a lot more for like malware analysis, for the kind of security research stuff. But like the kind of the most common job in cybersecurity, which is you work at an organization and you have to protect it, for whatever reason, the tooling there is all kind of enterprise. And I gotta say, maybe it's my background, but I don't actually trust enterprise tools that much. Near as I can tell, you pay a lot of money for a support contract and very rarely get you what you need. Whereas if you invest your money in skills on your team and you use enterprise tools when they make sense, but you don't trust the blinky box, then you're going to do better in the long run because the skills are inherent to your team, not based on any specific tool. Okay, plainly we don't have an apricot.jpg. Let's try the search again. See if we do any better. Nope. View source and file directory. That's a really important right-click option in Autopsy. We don't appear to have this thing yet. And that might just be because we haven't, analyzed too much of this. What is the processor architecture of the system? Well, that one we can answer. We can do that by looking at the operating system information. It's AMD 64. That one we can definitely answer. What is the logical size of the file strawberry.jpg in bytes? Let's see if we can find strawberry.jpg. The mailbox is a little bit confusing. It's not that here you have mail in Autopsy. It's your error. It's your run log, basically, for all of the plugins that are running. All right, let's try strawberry.jpg. Okay. View source file in directory. Oh, we found strawberry.lnk. We go find that. Susie Strawberry. Let's go look for... See, now we're in her file system, so let's go look for pictures. Strawberry.jpg. You love to see it. Size, 72448. By the way, this is like a weird CTF autopsy. I will say, like, if I were investigating this disk as, a suspicion of something malicious having occurred on it, or and let's say that often defer will happen not just because of a malware attack, but because somebody internally did something really bad. I wouldn't just be like bouncing around all over the file system. I would be doing a pretty systematic review of, images, databases. I would be looking at their web history. I'd be looking at file devices, USB devices attached, right? I'd be looking at what was running, looking at the registry, web history, web search, right? All of these things to look for things that supported the investigation, right? This data has to serve a purpose. It's not just to have it, right? So, for example, look at the Google searches that this was able to extract. Really, really handy. Oh, good. How do I nicely fire my stinky employee? Thank you very much. Is it okay to flirt with my secretary? No, by the way. And look, if you look at the file, you can see that this is coming from Tim Apple's Firefox browser history. So we have a lot of data here, but this is exactly what I'd be going through. And also, look, email messages. We don't have any right now, but if email messages are stored on disk, Autopsy's going to grab them. And that is crazy powerful. Interesting items in cloud storage. Whoops. Slack.exe. Super cool that all 6 users needed to have a copy of Slack.exe. That's not at all insane. Thanks, Electron. Which user has a photo of a dog in their recycling bin? Let's go find out. There is a recycling bin section here. Okay, there's one picture. Open in external window. Yeah, it's a puppy. Okay, so that was Hansel.apricot. What type of file is vegetable? Alright, we'll use the keyword search again and just look for vegetable. I don't know for sure, but this is looking like a lot of JavaScript to me. So I'm gonna say JavaScript. Nope. Ooh. Oh, very cool. Ten tools. Oh, interesting. Get credentials. That's handy. Nifty. Well, this is obviously getting a star. By the way, quick aside. Anybody who is like me and stars a lot of GitHub repositories, I gotta say, the most indispensable tool I have found is Astral. So this just links in. It's free to use. It ties into your GitHub account, and it allows you to tag your GitHub repos that you've starred so that you can search for them or organize them with tags a little bit more reasonably. So, because I don't know, maybe this isn't a problem for other people, but for me, I often think kind of by reference, and it's like, oh, I know that I started this cool GitHub repo that did this one thing. I can't remember what it's called, but now I don't have to because I'll have it tagged in Astral, and I can just go look it up whenever I forget about it. Okay, back to the thing we're actually doing. The file type is vegetable. We still don't have it. My god, Perturbator. You're kidding me. Yeah, we're not seeing vegetable just yet. So, what type of girls does Miriam Grapes design phones for? Target audience. That's interesting. How might we find that out? Well, let's go take a look at Miriam's documents here. She's got phone samples, LibreCAD. There's a sample phone. Let's open this. Ugh. Come on, view a new window. Try open an external viewer. Okay. That worked, but what kind of girls does Miriam design for? It's a good question. Now we can extract this zip file. And let's go take a look at that. Okay, just the same thing. That didn't help us too much. Okay, this playlist is killing me here. Oof. A little bit better. Well, if we don't have any information in here, what type of girls does Miriam Grapes design phones for? Target audience. We don't have that yet, but perhaps we're able to find some more information in, not email messages yet, but perhaps web search history. That's for Miriam. The Pear phone. Got it. Disco Girls. Okay. What is the name of the device? Not the Pearphone. The actual computer we're talking about here. That goes back up to operating system information. The name is desktop. What is the SID of the machine? Do. Is this the machine account? No. The machine account has its own SID, but I wonder... It would show up in the registry. I just don't know why we're not seeing a registry section here. These are the programs that are getting run. Yeah, okay. Well, let's go there. What does it want? Does it want the administrator account? Let's see if there's a hint here. Do you know what SID means? Yes, I do. That's not helpful. Oh, I totally forgot to tell you guys. I actually got some good news this week, which is that I passed my EWPT. I am an eLearn Security Certified Web Application Penetration Tester. I'll probably do a write-up about the certificate and the exam process pretty soon. Thank you. Yeah, it was hard. But definitely worth it. Norwegia, thank you so much for the follow. Yeah, I have to say, um, the eLearn security, the eLearn security exams are really, really solid. No. All right, we're just gonna. They're solid because they're practical. They are designed to emulate real professional work, and I really appreciate that. So that's actually a difference between, you know, the eLearn security stuff and like the OSCP. The OSCP is very capture the flag like, right? Whereas, and the timing is bananas. But with like the EWPT, you get like a week of lab time and a week of reporting time, and that's a little bit more realistic. And it's not that there's a flag on systems; it's that you have to go through and use the data that you discover to enumerate and further compromise systems, but there's no like you got it, there's a flag, just like there wouldn't be on a real system, right? You just have to go and get as much stuff as you possibly can from every system, and you got to make a real report. And that was, I think, a really, really exciting part of the process for me. Hey, Gromit. Okay. I have not taken the Pen Test Plus. I did the Security Plus. That was my first cert. You got a free voucher. Definitely do it. Sisa, also a good one. I studied for that, but I never took it. So I would say that's a multiple choice, right? It's not a practical exam. I don't think CompTIA has any practicals. They're all multiple choice, right? Yeah, I mean, I did the AJPT, which was practical, and I really liked that. Sisa is a good one. Yeah, I studied for it like a year ago. I think I could do a little bit better now, but at this point, it's like... Yeah. What kills me is the GIAC certs are, you know, like $10,000 a piece, basically. That's not reasonable. That's kind of why I'm really kind of bullish on the eLearn stuff, because the price point is right, and the price point versus content, because it's all practical stuff. Even if they're not DoD 8570 noted yet, once you have one of those, you're like solid if you wanted to do DoD work, which I don't, but somebody might. Yeah, maybe. I mean, it's not like DoD stuff moves particularly quickly. We found more copies of Slack.exe. Sisa is the best 8570 bang for your buck. I believe it. Yeah, I do not like the CEH. I studied for that one too, and after I noticed like just kind of how baseline it was essentially the Sec Plus with extra steps. I didn't feel like it was worth my time or money. I'm really annoyed that like the machine account should be in here. Alright, I'll get a hint. I'm here to learn. Let's dump the SAM registry hive. I did, but alright.
Sunshine is my destroyer.
This song slaps, even though it has a weird intro. Alright. I mean, we obviously already got... What's the tool?
Looking upon these frail creatures, one would not think that they could contain such power. One could rule the universe with it. You must find them for me and destroy them.
No, you didn't, Gromit, you didn't you didn't miss Security Onion. We postponed it because the VM was being a jerk. The problem is the networking requirements for the machine, like doing it locally, were kind of insane. So I'm kind of reworking the way that I want that to happen. And just because it's so beefy, it's taking me a little bit of time. But we will return to Security Onion, absolutely. I mean, yeah. Wait a minute, do I have my Kali box? I guess we just do it in there. I do. SAM dump, right? I need the system file and the SAM file. Ooh, that only does Windows Vista SAM. Where am I going? I need the system file too. Okay. Well, we'll put them in there. So here I have my SAM and system files. Throw them over here. And oh, but I don't want... I don't actually want the hatches. I want the SIDs. Alright. Is there a download button somewhere? Probably not free. Nope. Boo. Does cred dump do any better? Let me fire up the Kali again. I shouldn't have closed it. Alright, I think we're going to leave this one alone for the moment, just because it really thought we had it. We go back to... It wasn't this, right? We tried this one, the default account. Yeah, no dice there. How many web browsers are present? Well, let's see if we can answer that one. How many web browsers are present? Let's look for installed programs. Well, Internet Explorer. Firefox. Google Chrome. Wait, how many different Firefoxes are there? 75. I think 3. No? Was it 4? I hate this. IE, Edge, Chrome, Firefox, 2 versions of Firefox. Okay, 5. How many super secret CEO plans does Tim have? I'm sorry, what was that? Dr. Doofenshmirtz type beat. What? Let's go look for some user data here. What you got for me, documents? Secret.odt. Take over the world, destroy Google, release the new phone, fire Jim Tomato. So there are 4 super secret plans. Which employee does Tim plan to fire? Jim Tomato. What was the last used what was the last used username? I didn't start this conversation, but I'm ending it. What? There we go. So the last web browsing thing was Miriam, but obviously it was Jim Tomato. So how would we have discovered that? Date accessed. Interestingly, no. Still, it should have been Miriam. I don't know why they were saying otherwise. What was the role of the employee Tim was flirting? What was the role of the employee Tim was flirting with? Secretary, right? Because we saw that in the Google search. What is the SID of the user Susie Strawberry? Well, that one we know how to get. We're right here. I'm sorry, what? Okay, I gotta close this Kali window. It's killing me. Did you just want the last bit? Yeah. List the file path for the install location of the Tor browser. Let's go back to installed software. Let's just see what's in C here. Maybe it's not in C. It shouldn't be there. Program 1. Yeah, there it is. Cute. what was the URL for the YouTube video watched by Jim? So the way we're going to get that is we're going to go through web history and I really thought there was a way to filter this. If we do like a search for YouTube, of course we'll find it. But it might take a minute. Right? And this is looking for files. It's not exactly what we want here. So there are some neat tools in here that we haven't really touched on, right? Like the discovery tools, where we can find kind of neat stuff that was going on. But, and this helps us kind of parse through the forest. There's timeline, there's communications. So if I look at the communications window, it's a kind of neat visualization of what goes on. I think I need more data parsed to run this though. So for now, let's see. YouTube.com. How to hack into a computer. Great. What was the URL watched by Jim? Now, do we know this was done by Jim? We don't. It's the only YouTube video that we have. Well, let's view the source file. In the directory. Okay, so there, now we know that it's Jim. So we're gonna copy that. Okay, I didn't need the whole row. Which user installed the LibreCAD on the system? Well, we saw it in Miriam. How many times admin logged into the system? It says 10 times. What is the name of the DHCP domain the device was connected to? Where would we find that? On the disk. A lot of this is about, where stuff lives. Found a bunch of email addresses. That's really interesting. I don't know. What is the name of the DHCP domain the device was connected to? Where would this be stored on disk? I know what Okay, I have to say, the first hints for Cyber Defenders are horrible, and then the second hint costs you points, and I don't love that. What's the name of the DHCP domain the device was connected to? Okay, we'll look there. Look in Windows, System 32. This is, I think, doing this enough is a great way to learn even more about Windows internals. As a Linux guy, I find the Windows system both infuriating, but also kind of incredible, just because there's so much going on at any time from all different... You know, you're looking at a system that has decades and decades of not just technical debt, but also, you know, requirements for backwards compatibility. And, you know, you're looking at all of this architecture. It's really incredible. I do not see a DHCP location here. Let's search for DHCP and see if there's anything. I keep seeing it and then losing it. I don't have any details here. No, we don't want that. There's admin, local diagnostics results. Let's look at communications, see if there's anything here. Nope, nope, nope. Communications isn't network communications per se, it's often like email. That's cool. Is that one of our SIDs? No. It's cool that we have all those reports, though, right? Oh no, that's not going to be right. More of these. But I don't see network accounts or network information. Does one of these reports give us any of that? Not so much. All right, well, let's, you know, when in doubt, Google. So let's try Autopsy network. So okay, let's take a look there. See Windows System 32. So we were close. Config. Oh, but interestingly, we don't have software. Oh, yeah, we do. I'm like looking for files. It's a registry. Good job. And Microsoft Windows. Windows. It's a current version? Yeah. Current version. Network cards. No? Guess we don't have that. Oh, wait a sec. Windows NT? Microsoft. Windows. Yeah. Current version. Apparently, we don't have that anymore. Let's, now that we know the Windows registry, HTTP. Let's see if there's current control set services. Let's look for that. Full set services. Come on. DHCP, we're getting closer. Configurations. Close, but not close enough. VXD looks like someplace to look, so we'll try that. Of course, not present. Control set services. Yeah, we're in the right place. VXD. No. No VX. Nope. All right. I'm willing to buy a hint for this. I want to know where this lives. This is interesting information. Check registry vibes. That was, you know what? That was worth killing the points. Services TCP IP parameters. Okay. TCP IP. Parameters. That's super great information to know. Fruitinc.xyz. What time did Tim download his background image? Let's go look at his pictures. Users. Tim. Downloads? Nope. Pitches? It says Tim? Oh, it's in... Will Google convert this for me? No. But it's fine. I was just trying to be lazy. Okay, so it has to be 0405. Wait, yeah, because it's so 0405 2020. And UTC plus 7, right? Because it's before UTC goes back into daylight savings. So 1, 2, 3 midnight. Yeah, 3 a.m. How many times did Jim launch the Tor browser? I don't know. But I do know that we're at 12:30, so we've been on for a little bit. So we're going to call it for today on this, and hopefully this was a good intro to Autopsy. We'll play around with it some more, do some more of the forensic stuff. And then with any luck, we'll also get Security Onion going next week. So we'll have that to work with as well. So for now, we're going to call it. Thank you so much for hanging out. Enjoy the rest of your week. I'll be back on Tuesday doing Red Team stuff, and we are going to finish Swag Shop from Hack the Box. But yeah, be good to yourselves, be good to each other, and let's see if we can send you someplace cool. Does not look like there's anybody on that I know, but I'll let you go wherever you want to go. But for now, take care, and I'll see you next time.